Adding vector components by hand. There are two ways to find a resultant vector when adding vector components. The first is to draw the vectors by hand and measure the resultant, which is what this video will cover. The second way uses trig functions, sine, cosine, and tangent, to calculate the resultant. You're welcome to use whichever method you're comfortable with. Some find the trig method faster, though it does require more math. For drawing vectors by hand, continue watching this video. To use trig, watch the Adding Vector Components with Trig video. Vector A is 8 newtons in the vertical direction, and vector B is 6 newtons in the horizontal direction. Find A plus B. Vectors A and B represent the vertical and horizontal components of some vector which we're trying to find. Since vectors care about direction, the signs of the vectors matter. In this case, vector A is positive 8 in the vertical direction, meaning it is up, and vector B is positive 6 in the horizontal direction, to the right. In order to find the resultant, the vector sum of A and B, we will need to add A and B using the tip-to-tail method of vector addition. There are 3 parts to adding vector components by hand: finding a scale in which to draw the vectors, drawing the vectors in the resultant, and then measuring the resultant. The first step in adding vectors by hand is to set a scale so the vectors fit on the paper. I'm going to use 1 centimeter equals 1 newton because I know the vectors will fit. If they don't, you may need to choose another scale. You can now use the same method as unit conversions to calculate how long to make the vectors. Vector A is an 8 newton force, and I know my scale says that 1 centimeter equals 1 newton. So in order to get rid of newtons, I put newtons on the bottom, and I end up with 8 centimeters. Vector B is a 6 newton force, which will give me a 6 centimeter vector. Next, I'll draw the vectors to scale using the grid lines to stay straight in the horizontal and vertical directions. It doesn't matter where you start, just as long as the vectors fit. Since I know I'm going to be going up and to the right, I'll start near the bottom left. I'll first draw vector A, which is 8 centimeters and going up. You can see it barely fits. If it didn't, I'd have to find a different scale. It is important to draw vectors tip to tail, so I'm going to want to start drawing vector B from the tip of vector A, not the tail. Okay, 6 centimeters gets me to here. The resultant vector starts at the beginning of the first vector and ends at the end of the second. Now I just need to measure the magnitude and the direction of the resultant. The magnitude is the length which looks to be about 10 centimeters. Using my unit conversions, this means the length, or the magnitude, is 10 newtons. To find the direction, this is important, we usually measure counterclockwise up from the positive x-axis. I'll place the protractor with this point at the beginning of the vector and make sure that the 0 lines up with the x-axis. I then can measure up to about 54 degrees. For the second example, vector A is negative 9 newtons in the horizontal direction, or left, and vector B is 5 newtons in the vertical direction, so up. Again, find a scale, draw the vectors, measure the resultant. I know that since the 8 newton force barely fit, 9 newtons probably won't, so I'll choose a scale that I can fit more newtons on my page. Let's say 1 centimeter equals 2 newtons. This means negative 9 newtons equals negative 9 over 2 centimeters, or negative 4.5. And for vector B, 5 newtons equals 5 over 2 centimeters, or 2.5. Since this time I'm going left and up, I'll start on the bottom right side. Vector A is 4.5 centimeters. And vector B is 2.5 centimeters. Now let's measure the resultant. Looks like maybe 5.2. Converting that to newtons gives me 10.4 newtons. So now I'll measure the angle, again from the positive x-axis. So I'll put the center at the beginning of my vector and measure from the positive x-axis, so I'm counting up. This actually looks like about 151 degrees. If an angle were to exceed 180 degrees, I could just flip my protractor and keep going, adding whatever number I get to 180. For example, down here would be 180 plus 30, or 210 degrees.